Welcome students. Today we will be discussing the important regions of IR spectra and how we can easily interpret an infrared spectrum. So let us begin with the important regions of IR spectra. In an infrared spectrophotometer, infrared radiations of increasing wavelength is passed through the sample of the compound and the percent transmittance is measured. In our previous video lecture, we have seen the working of an IR spectrophotometer. Now, IR spectrum of an organic compound is mainly divided into two regions. The first is functional group region and second is the fingerprint region, which is again divided into three regions. So, we'll be discussing all these one by one. Now, let us begin with the functional group region. Here, there is a figure showing the wave number in centimeter inverse, and you can see two regions very clearly. The first one is functional group region, and second one is fingerprint region. So, functional group region, this region extends between 4000 to 1500 centimeter inverse, and characteristic stretching absorption bands of different functional groups, that is CHO-OH, C double bond O, COOH, etc., are observed in this region. The next is fingerprint region. The region below 1500 centimeter inverse in the IR spectrum is known as fingerprint region. So here you can see this below 1500 centimeter inverse. The vibration modes in the fingerprint region depends on complex vibrations involving the entire molecule. Now the fingerprint region is subdivided into three regions. The first is a region of between 1500 to 1350 centimeter inverse, a doublet near 1380 centimeter inverse and 1365 centimeter inverse shows presence of tertiary butyl group in the compound. Gem dimethyl shows a medium bend near 1380 centimeter inverse. Second is the region 1350 to 1000 centimeter inverse. Alcohols, esters, acid anhydrides, lactones, etc. They show characteristic absorption strong bands in this region due to CO stretching. Now, primary alcohols, they form two strong bands between 1380 to 1050 centimeter inverse. Phenols, they absorb near 1200 centimeter inverse. Esters, they show two strong bands between 1380 to 1050 centimeter inverse. Now, the third region, it is below 1000 centimeter inverse. So the presence of monosubstitution and also disubstitution at ortho, meta and para position in benzene are detected by most characteristic absorption in this region. A bend in the region 750 to 700 centimeter inverse shows monosubstituted benzene. CH double bond CH deformation at approximately 700 centimeter inverse and that at 970 to 960 centimeter inverse distinguishes between cis and trans alkenes. Now the next is, now let us see some important points that how we can, by the help of these points, we can easily interpret an infrared spectrum. So let us study these points so that we can easily interpret an infrared spectrum. The first one is infrared spectrum of a compound represents its energy absorption pattern in the infrared region. For the detection of functional groups, the functional group region is most important. And just now we have seen functional group region, that is the region which extends between 4000 to 1500 centimeter inverse, and characteristic stretching absorption bands of different functional groups CHO, OH, C double bond O, etc. are observed in this region. And for the comparison of compounds, containing the same functional group, fingerprint region is useful, and we have seen it just now also. The region below 1500 centimeter inverse in the IR spectrum is known as fingerprint region. Now, the position of the peak or the bend tells the presence of a particular group and the environments affecting the group. Further study of the spectrum reveals whether it is ketonic, ester, amide, etc. The presence of electron donating group and conjugation lower the wave number of absorption, while the presence of electron attracting groups raise the wave number of absorption. Next point is hydrogen bonding. Hydrogen bonding lowers the wave number of absorption. Lowering in wave number and broadening of band are significant in case of intermolecular hydrogen bonding. Intermolecular hydrogen bonding is concentration dependent, while intramolecular hydrogen bonding is not. The next is two different compounds cannot have the same infrared spectrum, but the infrared spectrum of enantiomers is the same. The absence of a band in a particular region is a sure indication of the absence of group or groups absorbing in that region. For example, if there is no absorption in the region 1900 to 1600 centimeter inverse, the carbonyl group, that C double bond O, must be absent in the compound. Next is always start from the higher frequency end of the spectrum. Mostly stretching vibrations occur in the region above 1500 centimeter inverse and are most informative. The region 1500 to 1000 centimeter inverse may be used for confirming esters, alcohols, ethers, etc. For easy detection of various groups present in the compound, the infrared region 4000 to 667 centimeter inverse may be visualized as consisting of the following portions. So just we'll have a brief discussion of these portions one by one. So the first is 3600 to 3200 centimeter inverse. The appearance of the bands in this region shows the presence of OH, NH2, NH group in the compound. The position intensity and the breadth of the bands tell whether the group is free, intramolecularly bonded, or exhibit intermolecular hydrogen bonding. Then comes 3200 to 3000 centimeter inverse. Absorptions due to CH stretching and ARH stretching occur in this region. The sharp ends of weak to medium intensities are observed. Then 3000 to 2500 centimeter inverse. The absorptions due to CH stretching from methyl group occurs in this region. A very broad band between 3000 to 2500 centimeter inverse is most characteristic of acids, that is COOH group. Two weak bands, one at 27-20 centimeter inverse and the other near 28-20 centimeter inverse are most characteristics of CH stretching in aldehydes. and then 2300 to 2100 centimeter inverse. This is the region in which alkynes, cyanides, cyanates, isocyanates absorb. The bends observed are weak and variable. Then comes 1900 to 1650 centimeter inverse region. Now strong bends due to C double bond or stretching occurs in this region. Anhydrides show two strong bands in the region 1850 to 1740 centimeter inverse. Esters, aldehydes, ketones, lactones, carboxylic acids, amides, they show strong bands due to CO stretching in this region. The next is 1600 to 1000 centimeter inverse. This region is very important for identifying nitro compounds and also confirming the presence of ethers, esters, primary, secondary and tertiary alcohols. And then last is the below 1000 centimeter inverse. This region is very useful in identifying the type of substitution and the aromatic ring. A strong band at 770 to 730 centimeter inverse shows monosubstitution. Ortho and para disubstituted compounds show one band each, and matter disubstituted compounds are usually recognized by two medium bends in the region 850 to 710 centimeter inverse. Now next here this is a table showing the characteristic absorption frequencies of functional groups. So there are three slides. This is the first one, this is the second, and this is the third. So these are the tables showing characteristic absorption frequencies of important functional groups. So in this table you can see there are four columns. The type of vibration is mentioned in the first column, then class of compound in the second. In the third, the frequency in centimeter inverse is shown, and in the fourth one, intensity is shown. So you can see in all these three tables the different types of vibration, class of compounds, and their frequencies. So by the help of this table, we can have a very clear idea regarding an infrared spectrum. So today we discussed first important regions of infrared spectrum, that is functional group region and fingerprint region, and then in the later part we discussed how we can interpret an infrared spectrum. So thank you so much.